Hello, I'm Tom Hopkins. I'm an assistant professor here at Bossier Parish Community College, and I teach programming. Today we're going to take a look at Python, input, processing, and output. And we're going to take a look at the part of it that makes a computer actually worthwhile or useful in our everyday life. We're going to take a look at the user input methods. We're going to look at a little bit of the processing, and we're going to look at the output. Now, programs are basically a static thing. Unless we can get some type of user interaction, the programs really don't do us very much good in the everyday life, so to speak. If we can't put what we want to get out of the computer, if we can't tell it what we would like to do as users, not as programmers, then the computer basically is just like the television or microwave or anything else. So what we need some process we need some process where the users can interact with input, such as telling it our name, putting in numeric values, or making some type of string, some type of statement. The input function reads inputs from the keyboard. Now, it always reads data as a string. We'll talk more about this, but you remember before we talked about data types. Strings are nothing but all text, including numbers, because if we use numbers, then numbers are going to look like and act like just an extension of the alphabet. Now, the format that we're going to look at for Python is some variable name is going to equal input, and then we need to prompt the user. Tell the user what we want them to put in, and you need to be specific about this. For an example, I've got a variable called name, and it's equal to an input of what is your name. So the user knows that what we want to have entered is a name. Notice also the format, there is a space right here at the end. If you can see it right there, there's a space right there. Because in Python, what it does, if you don't do that, then it's going to print what is your name, and the user is then going to print right at the very end with no spacing, which makes it look a little funny to the user. Let's take a look at this process in Python itself. I'm going to move this out of the way. And here is a Python file that I've already written. And what you're going to see here is you've got num1 is equal to input, type a number. And here you notice the space. And then num2, I'm going to ask them for a second number. Now, these two variables now can be used in a print statement or any other type of decision-making structure of whatever we want to use them for. If you'll notice here, I've got a print, and I usually right here, I will say in text what this number is going to be or what my result is going to be. That way the user knows what they've done, what is being used for. Notice too, I've got a print statement with nothing in it right here. What that does for us is gives us a blank line. And I've also got a wait with an input. Now this is more for the programmer, but what I don't want to do is I don't want the whole program to run yet. So I'm going to have it, I've given it a variable name, and I've just said input, enter, type enter to continue. Well, it's basically a blank input. Nothing will happen. It'll sit there and wait for the user input, and they can hit any key on the keyboard. They don't have to hit just the enter key, but it tells the user what to do. Okay, well, let's take a look at what happens with this particular one. You remember now that I said that if you type a number in an input, it's a string. Okay, well, let's take a look and see what happens when I run this. Okay, I've got to type a number up here, which is the input that I've asked for. So I'm going to type 21 and hit the enter key, and then it says type a second number, and I'm going to use 6. Now when I hit the enter key, you'll see that num1 plus num2, that's the statement that I have made, equals 216. I don't think so. What's happened here, once again, what's happened is we've typed two numbers, but remember I said the input then becomes a string. Well, if you try to add two numbers together, what happens in the print statement is it does something called concatenation. It connects or puts together the two variables with no spaces. So 21 and 6. 6 is just tagged on to the end of it, and we get 3 characters. Notice that they are not numbers. Well, let's continue, and I'm going to hit the enter key to get a new update. And here we're going to do it again, and we're going to put 21 as the first number, and 6 is the second number. And we get 27. Now we get a proper. Okay, how did that work? Well, let's take a look at back here again. Let's take a look at what the input does. The numbers, reading numbers with the input, an input function, like I said, it always returns a string. So we're going to make two mathematical type or data type functions called int, int for integer, and float, which is short for a floating decimal, and we're going to use that word to convert these items into an integer or a float. And what we're going to do, the type conversion only works if we've actually put numbers. If we put anything else, what's going to happen is the program will fail and throw an exception, as we say, and it will stop and tell you that it's not correct. So here's a couple examples of how I did that. Down here, you'll see that what I've done down here is I've said speed is equal to int, and then in parentheses, I put my input statement. Hours equals float, and then in the parentheses, an input statement. Now notice here you've also got double parentheses because input requires a parenthesis as well. Okay, let's take a look at another version here. Let's take a look at performing math computations or calculations. Now the math operator that we use is the standard ones that you're used to seeing, plus, the minus, we use a star for multiplication, and of course the diagonal for division. Now, there's a couple others we're going to talk about in just a second. There are two types of divisions. We can do a single diagonal, and that gives us a floating point division. So if we divide, say, 6 into 27, then what we would wind up with is a decimal. However, if we use two slashes or two diagonals, then whatever the result is going to be an integer. Now, the way the system does that, it doesn't round up or round down. What the system does is does something we call truncating. In other words, it just chops off the decimal, whatever it is. So if we have a result that is 6.9, but we've used the integer division, then we will get 6. We will not get 6.9 rounded up to 7. Now, if it's a negative number, by the way, it rounds back the other way away from 0. So that way we don't ever wind up dividing by 0 is what the bottom line is. Well, let's take a look at what we've done. We've got two terms here. We've got an operator, which is the plus, minus, multiplication, division. And then we've also got the operands, which are going to be the two numbers that we're going to add, subtract, multiply, and divide. if you remember back, some of you, at least when I was in school, we remembered this precedent or order of operation by "please excuse my dear Aunt Sally." Now, it wasn't quite exactly correct, but it at least kept us in mind which one comes first. So every mathematical expression will do anything in parentheses first. It will then do any exponents. Notice our exponents are 2 stars instead of, because you can't, in programming, it's difficult. We have no language that understands superscript versus normal script. And then we have multiplication, which is the asterisk. Division, we've already explained, and a remainder, which is a type of precedent or type of operator, which only gives you back the remainder from the division. So if you divide 2 into 5, well, 5 divided by 2 is 2.5. So we will get, but we will get the remainder of 1, because 2 divided into 5 is 2 with 1 remainder. And the answer would be a remainder. We'll take a look at this in a second. We also have division and subtraction. Now, of course, multiplication and division are very similar. Since multiplication and division are of the same equal line, then it will execute from left to right. Addition and subtraction, it doesn't matter which one comes first, so it will execute from left to right as the way you wrote it. Okay, well, let's take a look at what this does. Let me go ahead and close this out. Let me bring this one up front, and we'll just get rid of this one. Okay, let's take a look at this one then. This is a little program that I wrote that gives you every example of 10 plus 3, 10 minus 3, 10 times 3, 10 divided by 3, and also the integer division of 10 divided by 3. And I also gave you I'm showing you the 10 modulus. That's the magic word for that percent sign, a modulus or a remainder. We'll take a look at these first. Let's go ahead and run this so you can see what it looks like. And there it goes. And here you can see 10 plus 3 is 13, 10 minus 3 is 7, etc. Notice the 10 divided by 3. Remember, this is a decimal division. So therefore, we get about 15 characters beyond the decimal. And of course, if we let this go forever, it would go forever 3s. But here, 3 divided by 3 as an integer, notice that the 3's are all chopped off, and all you get is 3, and you don't even get a decimal. And of course, 10 divided by 3 gives you a modulus or a remainder of 1. Now, we'll take a look at the other one. Let's take a look at this one where I have made a program or a mathematical expression where I've taken 10 plus 3 minus 9 divided by 3 times 2. Well, if you look over here, you'll see on the left, you'll see that the answer is 7.0 because I used a floating point division. Now, the way it breaks down is this. Because of the order of precedence, then 10 plus 3 is, what's done first is the is the 9 divided by 3, which gives us 3. And then we're going to multiply by 2. Remember, because division and multiplication are equal, then we're going to do the division first and then the multiplication left to right. So we've got 10 plus 3 minus 3 times 2. So next in the order is 3 times 2 then is equal to 6. So now we have 10 plus 3 minus 6 which gives us the answer of 7. Okay. Let's go back to our slides for a second. So we've covered the way the precedent goes, the order of precedent. We've talked about exponents before. It raises a number to some power, and in this case it would be x, and you'll see the 2 multiplication symbols. And we've also talked about the remainder and the modulus. Okay, now it's your turn. Write a program that computes the distance traveled by a train going some speed in miles per hour for some number of hours. Of course, that speed in those hours should be a user input. The speed can be an integer float, but the hours should be a float to allow us to allow the system or the user fractions. Ask the user to input both speed and hours traveled, and then print the number of miles traveled. Real simple little program. If you want to stop the video at this point, to go ahead and do that, then would be a good idea. They'd give you a good chance to practice. Then you can take a look at the next slide, which will give you the actual answers. And that gives you some hints anyway, not the real full-blown answers. Okay, so what we've done now is we've taken a look at how to write an input by the user, how to use the variables in those inputs, how to process the math expressions, and also formatting the output so that it makes sense. Okay, and that will conclude today's segment. Have a good day.